And you're going to show screen, help. And then a little bit of me. So I'm going to actually talk with my hands a lot. It's a bit of a habit. When I'm talking about like smaller things or bigger things, it's usually a lot easier. If I have the screen on, at least in your corner, I do have a face for radio, so be forgiving. So what the main topic here is new REACH SVHCs from January of this year, and they were proposed last August or so. Went through long consultations. By about November, we have a pretty good idea of which ones are going to become SVHCs. The only one that was up in the air is melamine, and Austria, which eventually abstained, had a really good point. The fact that it's not particularly dangerous. It's actually funny, when we got melamine into the lab here to see as control samples, one of the interesting parts, when we look at the safety data sheet, basically this stuff's pretty inert. But Austria abstained, and so since everybody voted on the SVHCs, voted in melamine and SVHC. And that was the only one that was up in the air. But by November, we made a pretty good prediction that the new SVHC list would be published January 17th, 2023. We nailed it on the dot. So take this in mind, when I talk about the EU PFAS restriction timeline, or the most aggressive timeline, that we're actually pretty decent at understanding what's going on in the background. You can shift around some of the dates and such. It's probably going to be farther out than what I'm predicting. They'd like to make it sooner, and they try to start with sooner, but there's a lot of other steps they have to go through. So I'm going to talk about the SVHCs and the risk of their presence of all 9 of them in articles, and if they're present, why and where. And of course, you're really not doing this for your health. You really have to, put this in the SCIP database. Any product with an SVHC in it, the over 0.1%, the SVHC, the component, and the product has to go in the SCIP database. And I'll talk about also our process for updating current SCIP files. We've done a tremendous amount of SCIP. We're easily the most effective and efficient. I'd say almost all the best SCIP declarations are ours. They're also probably the most efficient. We're a big fan of looking what the output is needed and what's the best solution to that output. And the solution might be different. The solution may, be different than, the commonplace at the time. It's really what is the best. The idea is not to hammer home the same solution that you've been selling for years to do something different. It's basically what is the best solution. How to actually create the SCIP files, how to update them, especially with these new SVHCs, which should cause a change or update for virtually all electronic products because of the number of flame retardants that are new SVHCs. Then we're going to have a little diversion. We're going to talk about single-use plastic regulation, mostly about Spain, which is the most tangible, but a little bit about the United Kingdom and what you're seeing. And then we're going to talk about the uses of PFAS. And I talked about PFAS quite a bit, my last webinar, last month now in January. But I'm going to talk about first the restriction timeline in the EU, so a little understanding of what's going on and what all the different points are and all the steps that have to occur and why when they publicize their grandiose plan 6 days, that is the biggest it's going to be. It's going to be refined down from that point and how long and how it gets done. And then I'm going to talk about a lot of the PFAS uses in physical products. You might be surprised where they're used. Then I will separate between intentionally used, which is the ones you declare, like for Maine, or eventually US federally, and which ones are restricted, which are currently already restricted in the EU. And then we'll do a little bit of Q&A. So because of that, I'm focusing a lot on the start of this year. There's a lot of stuff kicking in. As much as people are focusing on the potential PFAS restriction in the EU, the main reason they're being restricted is something that's already restricted as of February of this year. And it's the long chain, PFOA and longer, long chain perfluoroalkyl carboxylates. That's the hazard of them. And the hazard's already regulated, and it's regulated in February. And if you don't know where your PFASs are already, then you're not going to make this restriction. And it's just a matter of whether EU checks your product or not. It's really that simple. The PFOA and the LCPFAC restrictions are so strict. If you already don't know where your PFAS is, well, guess what? You're not going to pass this one. Main reporting is theoretically January, which just occurred, except for almost everybody's an extension, but that's only June or July, guys. Spain single-use packaging tax just kicked in, and then what we're talking about today primarily is the new SVHCs. So very busy start of the year. It's always interesting so the reason why I'm so much interested in PFAS is because it's at a regulatory stage and it's still in development, which means your associations and other entities that lobby are very fascinated with it and putting and passing on information. And if the sky is not falling, nobody wants to pay their association, which is fair. And so at this phase in the regulation, sky is falling. Realistically, the PFOA, the long chain before alkyl carboxylate, the PFOA and longer ban as of February this year, if you don't know where your fluoros are up at this point in time, you're going to run afoul of this restriction. It's kind of amusing, but it's well past the lobbying phase. It's already been restricted, so the associations are less interested. We find generally what people are panicking about are either something that just had enforcement, which outside of food contacting and medical is pretty rare right now, or it's at a lobbying phase. The more it's in a lobbying phase, the more panic. The more intangible it is, the more panic. The fact that it's already in place, less panic, because a lot of the people that are trying to control a lot of your information, like your association, are not as interested in it if it's already implemented. There's not a lot of money in it for them at this point in time. Like most things in life, follow the money. And that's hilarious. Sorry, for anybody who attended this morning, I fixed a dyslexia chemistry moment. I'm going to do that again in all the slides except for this one. Tetrabromophthaleate is TBPH. It's funny, I must have copy pasted a million times of this. So there are 9 new substances, not to berate myself there. There are 9 new SVHCs. So as of about November of last year, by at least early December, it was a pretty well done deal that 8 of these going to be an SVHC. The only one that was up in there was melamine. And melamine, fair enough, Austria was like, are we really doing this? Because melamine is pretty inert. Don't put it in baby formula because it's a category 2 specific target organ toxicity. Chronic exposure, long-term exposure. So it may have a hazard if you eat it every day of your life. So don't put it in baby formula. Otherwise, pretty inert stuff. But Austria eventually withdrew their opposition, and since everybody who voted was unanimous, all 9 got in. And as I mentioned earlier, we originally guessed back in November, December, that it was going to be January 17th, and we hit it on the day. So of course, we're going to probably say that quite a few times. There's a pretty good guess, but it has a lot to do with we understand how their processes work. And based on when a previous step occurs, it kind of dictates when the next step occurs. If it's European Chemical Agency, it's very stepwise, which makes it very predictable. And that's the difference is between REACH SVHCs and the RHS exemptions. The exemptions, the EU Commission, which doesn't have this infrastructure. And when or if they're going to be done anything is really up in the air. Regulations in the chemical side in the EU are governed by the European Chemical Agency, which has a more regular, predictable, consistent operation. So the first one of this, so we're going to talk about first most of the SVHCs that won't be in your product. There are some very specific exceptions. We'll talk about those. So this is a reaction mass, mostly morpholine. It is a fluoromorpholine. It's basically 3 different PFASs. We'll talk about later, one of the major uses of PFAS substances is this thermal cooling for electronics. So to pull heat away from electronics. If you have liquid coolant or gas coolant, this could be in there, but it's in a chemical. So when I talk about lower high risk, it's always going to be in about physical products. Chemicals can always have them in their SDS, but the SDS is a pretty easy read. So it's just 3 different PFASs merged together into a single material. And its cooling product. Now, the main manufacturer of this is pulling out of the PFAS market, even though it's quite profitable for them, because of lawsuits from legacy factory operation. But it's a cooling product for electronics. It pulls heat away from the electronics. But it's PFAS, but physical products won't have this. This is a liquid coolant, be governed by safety data sheet, etc. Perfluoroheptanoic acid, and it's basically 7 carbons. Heptanoic is 7. Octanoic is 8. Is it used? Probably extremely rarely. Generally, the PFOA is used as a surfactant in the manufacture of fluoropolymers. And if C8 is not used, perfluorooctanoic acid, they switch to C6 or C4. So 8 carbons, or hexanoic, which is 6, or butanoic, which is 4. It's always even numbers for whatever reason. Heptanoic is an odd number. So it could be used, but we haven't seen it. We've seen hexanoic lots. We've seen octanoic lots. Heptanoic, no. It's a processing aid or unintentional contaminant. It'll be in the sub 1 part per million. So nowhere near 1,000 ppm. And it's short chain, so it's not REACH restricted at this point in time. Basically, it's a substance that is not going to be in physical products even remotely near 1,000 ppm. If it's there as a contaminant, unregulated contaminant, it'll be sub 1 part per million, which is not even close to declarable. It's also quite rare. It's an odd number for perfluoroalkyl carboxylate. It's an odd number PFOA, which makes it pretty darn rare. This one is super common in moisturizers and glitter and hand body lotion. It's parabens. Parabens are generally a pretty bad idea in cosmetics. They really need to go. You know, it's funny, I'll say lots of, you know, things about PFAS and fluoropolymers, and fluoropolymers are about as inert and benign as you get. These are not. This is isobutylparaben. And the right side of the molecule, so you see that little benzene ring, the hexagon with a little OH sticking on it, that's a phenol. That's a phenolic group. That is just like the end of estrogen. Estrogen is also a phenolic group. So what makes these estrogen stimulators or estrogenic substances problematic has to do with a phenomenon in your first year of life. In one of the previous webinars, I talked about this. And if you take anything away from the health and chemistry of this, take away this piece of it. This is the mechanism for bisphenol A. It is after metabolism by your body, the mechanism for DHP, and why they're harmful. Particularly DHP is the worst because its concentration level is so ridiculously high. If you have an estrogenic substance like this one, and it simulates estrogen in your first year of life. So when you're born, you start with a ton of brain cells, lot, and they're not attached to each other at all. And it's kind of a random walk, but over your first days and months and weeks and months of life, they start to connect together. It's kind of a random walk, and the baby starts to move his fingers, makes eye contact, then she flips over. And what the child is doing is inside the brain, they're randomly connecting different brain cells until they create pathways that do something. And if the pathways does something useful, they generally keep it or build upon it. Not all the brain cells get connected because it's a bit of a random soup they're starting with, and it's basically randomly connecting. By about 1 year of life, you've actually created most of your neural pathway. Your wiring through brain is basically created. It's kind of like when you're making a field programmable FPGA or similar chip, but very, very complex. And so about that time, you still have all these brain cells lying around. They're not connected to anything. So your brain undergoes apoptosis. And it's basically, you have a program in your brain that goes around and asks each brain cell around 1 year of life whether or not it's doing anything useful. And if it's not doing anything useful, it tells it to commit suicide. You kill off about half your brain cells at the end of year 1. And it basically kicks out any brain cell that could interfere with the pathway because it's not attached to anything. The idea is to keep all the pathways that exist and get rid of all the cells that aren't connected to something. And that really locks most of your neural network for the rest of your life. You'll use it more creatively and so on and so forth. What happens, unfortunately, when they make that decision process on the brain cell, hey, are you doing anything? The chemical involved in that decision question is estrogen. And if your estrogen is off, if you're using estrogen simulating substances, estrogenic substances, they can make a mistake in that question. And what can happen is some brain cells that aren't doing a lot, but are being used, might commit suicide, might undergo apoptosis because the decision process, it's a chemical decision process, is off. And what happens to these children is they end up with fewer pathways. They keep their main ones, they lose a few of the peripheral ones. And it doesn't normally affect IQ at all, actually. What it does affect is bandwidth. They have less pathways, they have less bandwidth to process information. And so when they're overstimulated, like inside a classroom, especially if they're at the back of the classroom, they're overstimulated, they can only take so much input, and their limited pathways become overloaded, and it creates a burning sensation and basically discomfort because they're being overused. And the children often act out in 2 different ways. They either act out, and that's the most obvious ones. When the teacher and the parents notice when the child's acting out all the time, especially in classroom where they're vastly overstimulated, or they develop a safety mechanism. So there's ADHD, attention deficit hyperactive disorder, and there's inattentive ADHD, which is what they've done is the child has developed a safety mechanism where they shut off stimulus by going to sleep or otherwise losing eye contact or losing concentration quite dramatically. And basically fading out or looking at or going to sleep or daydream or whichever, that's a safety mechanism for ADHD. And it's basically overstimulated, their pathways are overwhelmed, they're being burned, and so they shut it down. Where it manifests in adult, which is probably the most interesting one, is a lot of the ADHD adults have developed the safety mechanisms by then. One of the downsides of safety mechanism, you often respond to overstimulation by sleep. And one of the most common ones for adult ADHD is bright sunlight while driving is a vast overstimulation, and you fall asleep. It's really weird where a lot of the ADHD people will fall asleep driving in bright sunlight because it's an overstimulation. Put sunglasses on, they don't. It's kind of a neat thing. And so where a lot of this comes from is estrogenic substances that affect this decision process in the first year of the child's life, and that's parabens. So back on to physical products, it's a chemical in moisturizers and hand lotion. It's not in physical products. So not a problem in physical products. However, it is, you flip over your ingredients up in your cosmetics, it says paraben. It's probably a bad idea. If you're male over a certain age, it doesn't really matter. If you're a woman over childbearing years, not really a problem either. You're playing with your estrogen a little bit, but it's not really that bad. If you're a woman that could have children or you're under the 1 year of life, it's probably not the best stuff to be near. There's a lot of reasons why it's not heavily regulated. It's a complicated question. Not a problem with physical products. So one of the things we do, and it was on one of the previous slides, I just didn't really mention it, is for people who do our quarterly or monthly updates, where we sit down every month or every quarter and we go over this sort of thing and how it affects your product, and just with you, and it's very dynamic, and you ask lots of questions. Say, hey, I'm making one of these things, I have this new product, how does it affect things? Or, hey, wait a minute, we have one of these, does this regulation affect that or not? Is also we provide these when chemical list changes, like the REACH SVHC list, the Prop 65, there's a new REACH restriction, a new POP restriction. We provide a single one pager, which actually explains the chemical, whether or not it's a risk in your product, if so, where is it, and to provide you a justification of why you do or don't have to do something. And in many cases, why you don't have to do something like these chemicals. This is for the ones that are part of that. We'll probably release ours next week. The main reason it's delayed is this chemical. It's a very complicated one to explain. It's barium diboron tetraoxide. It can be up to 10%, 100,000 ppm coating, but it's an acrylic primer, and it's structural. So you're looking at mostly walls. We don't see acrylic paint very often on physical products. But the way it works out is even if it's up to about 10% barium diboron tetroxide, which is normally it's much lower. Normally it's well below 5%. It's at most about 770 ppm concentration. This is structural. And this assumes none of it dissociates into salts and into different chemicals. So it's pretty darn low risk. We just want to make sure we dot the I's and cross the T's. It's really just acrylic paint primer, which we don't see in a lot of products. We're more likely to see powder coating in that kind of space, in physical products. But it is pretty well low risk. If you're selling primer to redo some of your products, it might be in there, but that's a chemical SDS thing. With the SVHC, any chemical is a chemical until added to an article. Anything in that chemical for article purposes is measured over the weight of whatever it's painted on, not the weight of the paint itself, but everything that's painted over, or if it's an adhesive, the things it's attached, any concentrations are measured over the whole group of things it attaches. So it makes it pretty low. We had double check. So the barium diboron tetraoxide has a significant use in acrylic primer for structural items like walls, but in physical products, even if it was on your physical product, it's not expected to go over 1,000 ppm. 4,4-sulfonyl diphenyl bisphenol S. It is really common, extremely common. We test for it all the time. One of the reasons we test for it all the time is in our lab, we use different thermal papers to seal our bags. And anything that potentially touches our samples, we have to test. And thermal paper has commonly low concentrations of bisphenol S, which in general is allowed for our applications. It usually has sub 100 ppm, usually in the 30 ppm range of bisphenol S. So if you have thermal paper printouts, they're almost always going to have bisphenol S on them. We do multiple manufacturers, et cetera, because we have a lot of alternative suppliers for our internal labels. They all have it. It's differing amounts, they all have it, but well below 1,000 ppm. Someday, if they ban this under the BPA restriction, the BPA family restriction, there might be some problems depending on what concentration they go with, but it's low concentration in thermal paper, well below the 1,000 ppm declarable limit. So those are the 5 low risk ones. The next 4 are all the same application. They're all flame retardants, primarily for electronics. You could see them in oil and gas and other flame retardant situations, but they're flame retardants. And so this is tetrabromophthaleate. It's literally DHP with 4 of the hydrogens knocked off, and bromine's put there. That's brominated DHP. It has the capabilities of DHP. It's a plasticizer, but it's a brominated, so it's also a flame retardant. A brominated flame retardant always has antimony. Basically, bromine is a very little use as a flame retardant on its own. Basically, when plastic burns, which has, say, the brominated flame retardant in it, imagine this is a wire and cable, the hydrogens pop off from the burning plastic. They're very excited. As the flame retardant burns, also the bromine pops off. The hydrogen and bromine react, creating hydrogen bromide. The hydrogen molecule is very, very excited at that point in time. It releases its energy into the hydrogen bromide. Bromine's much larger, so it absorbs a lot of the energy, but not enough. And some of the energy will be kicked back into the plastic and it'll keep burning. So that's why they add antimony trioxides. The hydrogen reacts with bromine, creates hydrogen bromide. It absorbs some of the energy, but it's still overexcited. It would release energy back into the plastic, which creates more burning. And antimony trioxide comes along and reacts with it. Antimony is a much bigger molecule. It can absorb even more of the energy and from the hydrogen bromide, and less gets kicked back in the plastic. And that's how a gas phase brominated flame retardant works. Pretty common, pretty useful. It's a great way to do flame retardancy. So when you have a brominated flame retardant, you're going to have antimony trioxide. It just doesn't work very well without it. Where we see this, PVC, chlorine, flexible, plasticized, brominated with antimony. Anytime we've seen the flexible PVC with bromine and antimony, we've always seen this over 1,000 ppm. But again, you're looking at flexible flame retardant PVC, so cables, power cords, wiring, it is relatively common. It's usually with another orthophthalate, historically with DHP, but more often now with DINP or one of the less regulated ones. We're looking at power cables and other wiring and cables that need flame retardancy and flexibility and are PVC. So this one is relatively common, but a very specific application. When we test for it, if you see chlorine, bromine, and antimony, we get tetrabromophthaleate. Melamine, this is the one that was controversial, whether to be added. It's not controversial because it's dangerous, because it's generally pretty low on the danger scale. Where most people know about it is first from melamine, I want to say poisoning. Well, technically it's poisoning of children's baby formula in China, because it comes off as a protein concentration in the test because of nitrogen. However, it's relatively harmless. Just don't put it in baby formula for child's consumption. Where we all see it in regular life is melamine cookware, tabletops. That's melamine formaldehyde. It's a different chemical. It's not this one. Melamine cyanurate is the problem child. So melamine cyanurate is also a different chemical and not melamine. However, even if you look at the European Chemical Agency's listing for melamine cyanurate, you'll see melamine and cyanurate. They're not well bonded. They're a Lewis acid base pairing. It's not well bonded. So when we see melamine cyanurate, we often see melamine unbonded in the part. So we see polybutylene terephthalate, PBT, and nylon electronic components use melamine cyanurate all the time. Those are hard parts in electronics. Some good examples, this material declarations for the part on the right, capacitor, that's melamine cyanurate, and it's also melamine polyphosphate, which probably degrades a bit in melamine too. Whether it's over 1,000 ppm, that's a good question, but they all use a melamine-based flame retardant, as do the terminal blocks down below. Melamine is the probably most common larger hard component halogen-free flame retardant. So they moved to halogen-free, they moved to melamine, which is less harmful by a good mark than bromine, which is way less harmful than the main replacement. So a lot of the smaller electronics, they use a phosphated flame retardant. Those are dangerous. Those are actually estrogenic and a bad idea. The brominated ones aren't so bad in general. They might be bioaccumulants because they don't react with stuff. And melamine is none of the above. It's really don't put it in baby formula. So it's declarable. It's not restricted. Melamine cyanurate is also pretty inert. You could eat it. I wouldn't eat a lot of it, but you could. But it is relatively common as a flame retardant. It's funny, your laundry detergent's way more dangerous than that stuff. Firemaster 680. So this is another brominated flame retardant. It's been phased out years ago to the point where most labs, including ourselves a couple months ago, didn't have a test for it. Even we're testing brominated flame retardants. Nobody tested this one. This phased out a long time ago. Where we could see it is recycled plastic, but generally around 100 ppm. This one's pretty low risk. It's also pretty poor brominated flame retardant. It only has 6 bromines. That's actually not very good. Deca BDE, which is the ROHS one, has 10. and it's far more effective. The more bromines in the molecule, the more effectiveness of the flame retardant. So it's not a very good one. It's mostly phased out decades ago. You might see the recycled plastic coming through from decades old plastic, but generally we're not seeing it in any. Of course, we only started testing recently for it, so we have very little data. So it could be there, but it's very unlikely to be there. This one's gonna, if you're gathering data from suppliers, this is gonna drive you nuts because you're gonna be falsely declared like you wouldn't believe. Tetrabromo BPA, the additive version, was phased out years ago. It's really not used. We do see it in recycled plastic for sure, all the time. But in the sub 100 ppm range, so not like this, it's residual. Now, the main use of the tetrabromo bisphenol A is in BDDP, which is a tetrabromo bisphenol A dibromo ester, I believe. It's got 2 extra arms. So tetrabromo bisphenol A is a pretty poor flame retardant because it only has 4 bromines. BDDP version of this, which has 2 extra brominated arms, has 8. It's what's used. It's a different chemical. It's not this. And also, you get declaration for supplier. There'll be tetrabromo bisphenol A diglycerol ether resin. That's also a totally different chemical. That's tetrabromo bisphenol A attached to a diglycerol ether on both sides, actually. It's a totally different chemical. Also not tetrabromo bisphenol A. But there are a lot of things that use the name, like BPA epoxy is not BPA either. It's BPA diglycerol ether epoxy. Often it's badge. It's a very different chemical. There's a BPA in it, but it's not BPA. And so this will also soon be, well, I'll say soon, not that soon. If the new REACH substances were controlled by the European Chemical Agency, this would be an REACH substance by now. The EU Commission agreed it's approved to be an REACH substance, but the EU Commission, which is how directives are handled, doesn't have infrastructure for this, which is why the REACH exemptions, which is also EU Commission, have dragged on forever, the renewals, with no end in sight. That's why the new REACH will move to a regulation, guaranteed, to be run by ECHA. And so it'll follow the ECHA processes like REACH SVHC does, and things will be on a schedule as opposed to someday, maybe. Not they necessarily want more regulation, it's just very inconsistent. So tetrabromo bisphenol A could be in your product, but it's really been phased out a long time ago. Now, supply chain will declare it all the time, incorrectly, because it's really a tetrabromo bisphenol A resin, which is diglycerol ether chemical, which is a totally different chemical. Or if you try to buy these online in Alibaba, try to buy tetrabromo bisphenol A, you end up buying BDDP, which is the tetrabromo bisphenol A dibromine ester, I think. It's got 2 extra arms. I think they're ester arms, but I could be wrong. BDDP is the real name. And it's tetrabromo bisphenol A base, but it's not tetrabromo bisphenol A. It's got 8 bromines, makes it a lot better flame retardant, but it's not this one. So again, there are 9 new ones. If we've done, this should impact virtually the skip declaration of all electronics. If you're not electronics, unless you have heavily flame retardant parts, it shouldn't be a problem. The 4 high risk ones are reasonably high risk ones with different degrees of risk of being in your product are all flame retardant. So you're looking at electronics primarily. Maybe a little bit of oil and gas, maybe a little bit of protective equipment, primarily electronics. If you've done the work for you before, it's a really straightforward to update your skip. But it will impact pretty well every electronics skip declaration. They're pretty common. So the REACH SVHC is so important because you actually have to put it somewhere. It goes in the skip database. So as of 2021, you have to put it in skip database, and now it's public and accessible, and people can take a look at it. What basically has to go in there if your product has an SVHC, the SVHC, like lead, the component, like the connector, the situation, it's inside metal brass, and the product itself has to be in the skip database. So in this, we're adding terminal blocks, melamine, and then safe use instructions for melamine are pretty permissive. Don't throw it out in the regular waste stream, that's about all. So you have to update your skip, it's mandatory. When in doubt, we're the best. It's really a Lego project. You build building blocks of different declarable types, whether it's 3 or 5 is really not a big deal. You can put a range in the number of parts with it. You can have 3 to 5 or however. You just need to declare them and declare them properly, and it's pretty straightforward. So if any trouble with skip, we're really good at it. First off, if you've never done skip with us before, we explain the whole rule system. It makes everything so much easier going forward. Then we do it for you. Depending on how much work you've done, we can reuse some of your work, but it's really straightforward. We just create the declaration for you, and then we'll give you the files to upload. both an uploadable file and a PDF so you can see what's in it. If you can upload it yourself, awesome, it's pretty straightforward. If you're having challenges, we just log into a web meeting, look over your shoulder, and help you upload it. It's really straightforward. So if you haven't done your skip, it's mandatory. If you have an SVHC, if you have electronics, you're already going to have lead for some of the exemptions. It already needs to be in there. We can do it for you. If you've already done a skip, whether you've done it with us or separately, we can just update it. We know exactly how to do this. Even if you haven't done it with us originally, it's straightforward. Now, if you've done it with us originally, we actually planned for this. We set up our system that makes updates really easy. I mean, we've known these updates are coming. We didn't know which substances, but we know when and that they are coming. So we structure our whole skip process to make it pretty easy to tack on to using the same process, previous declarations. Pretty effective way to get to the answer you need. So when in doubt, if you've done skip declaration, whether you have or have not done a skip declaration before, just contact us. When in doubt, at least can tell you what we're going to do and how much. You can decide whether it's a better way to go. We've done tons of this. The best declarations out there are ours, but they're probably in many ways some of the least effort because our system is very, very, very efficient. The way we handle it is very efficient. The idea is not to get the best reasonable declaration for the least effort. The idea is not to, you're trying to sell product, trying to be compliant. The idea is not to make your life difficult forever. It's really to achieve the goal and move on to the next new thing. And there are a lot of new things. We showed from the first slide today. There's a lot of new stuff this year, like this one. So again, SVHC skip, we can handle it for you and just fix it. If we're doing any other work, you have a new product, you're doing testing with us, which is the easiest, fastest way to do full compliance globally, we can just tack this on. It's really straightforward. Our process is made to be very, very parallel. So you're going to see a lot of single-use plastic packaging regulation in Europe, and it has to do a lot with the EU as part of the COVID recovery, is taxing all the member state for single-use non-recycled plastic packaging. And so you'll see in Spain, you'll see it in the UK, even though it's not EU, and Italy to a lesser extent. And you can see this in most EU member states, because as the EU taxes them for single-use plastics, they're going to probably want to turn around and tax you guys. So Spain's one of the most tangible ones, went into effect in January. The UK's went into effect actually last year. The UK's is 0.2 pounds per kilo, I think. Spain's 0.45 euros per kilo of non-recycled plastic packaging, and includes primary, secondary, and tertiary packaging. So you have your product, the packaging around your product, primary. The packaging, the box or whichever, which has all the packaged products inside, is secondary, and then the overwrap and the pallet is tertiary packaging. All of that, if it's plastic, is in scope. So you need to know how much of each you have and be able to report it to the authorities in Spain and UK, and soon France and Germany and many other places. You're already if you're selling to Spain, you're probably already getting this question, and we can handle it for you like everything else. There's exemptions in Spain for medical device packaging, pharmaceutical, farming packaging. So basically, those hay bales that they look like big white marshmallows out in the field, the white. There's exemptions for that. Really low tonnage importers of packaging, and then recycled plastic. So if you have recycled plastic and it's certified, then you don't have to report it. Now, the fact you don't report it means that they're unlikely to actually ask for the certificate because you're not reporting it. Unless you report nothing, then they might have questions. So we do lots of this. This is actually, it has a company name, but it's actually just a desk chair that we bought for the lab. And so this is just off the market, common market. There's no other compliance requirements here other than just declarations. This is just weights. Anybody can do this. Well, maybe not the plastic type. We're pretty good at that. But it basically provides a report. They know what they have to report. Some countries you have to do material types separately. How much high density polyethylene, how much low density polyethylene, polypropylene, PVC, etc. They have, and then if they want to look in detail or they think they might have recycled material, we have a line by line version. We do this in parallel to other things. This might look like it's very expensive. It's not. You get a huge, we're very, very efficient way to do everything here. It's very straightforward. But say, where do you do this the most? We're testing something else with you right now. Just put the single-use packaging in. It's for the a couple $100 of work. It's worth that answer that you have to do yourself. Considering what else, all the other things going on. So, as I said, I'm going to go over a lot of stuff that is kicking in this year, and one of the things that gets huge amount of questions, mostly because of Maine, but also because of the potential EU restriction coming up. PFAS, and I had a webinar last month about this, and I'm going to talk today a lot more about one, the EU restriction, and because I'm talking SVHCs anyways, on the REACH side, and where it's actually used in physical products. And there's a lot of confusion, and I think a lot of the authorities could use an education too, be useful for them. So basically, but fundamentally, you can just sort of phase out in the chemistry right now. When in doubt, we can take your products, do work of which we don't need a lot of help from yourself. We're pretty good at this sort of thing. We tell you exactly what you need, and it shouldn't be much work at all. And then we can create the reporting for your customers or for Maine or for the US federally soon. And we can create the due diligence on the restriction side. So PFOA is, so the long chain version of PFOAs are banned in February as of this February. It's a real restriction. If you don't know where your PFASs are, there's no way you're meeting this one, because the chemicals that are restricted are in your PFASs. If you don't even know where your fluoropolymers are, so they're smaller unintentional PFAS in your intentional ones. If you don't even know where your intentional fluoropolymers are, you can't meet the European restriction, which is February. So we provide you the due diligence and restriction results, so you're compliant with the EU restriction of today, not the 2027 version or so for PFAS that everybody's worried about, the one that actually is very applicable this month. So one of the things we talk about where it's used is it's also, you have to understand why it's useful. Fluoropolymers are inert. They're very useful because they have low surface energy. Low surface energy on the surface of the material means it doesn't grip with other polar items. So water, it's very water repellent because water won't attach to it. The water is very polar, and PTFE has virtually no surface tension or energy, so it won't bind it. So this affects the friction. If you get to, so PTFE is incredibly water repellent. It's also oil and stain repellent. And because it has no basically surface energy, it has no friction. Friction is normally the surface energy, the two materials, they bind, they share electrons, and they grip. It's almost like small bonding. PTFE has none of that, so it just slips. That's why, you know, if you grind down on your brakes to metal on metal, it's spectacular because they're really high friction. You can look at the metal ones, the glass down the bottom, super high friction, as opposed to silicone and PTFE, which are very low. Silicone's downside is it's quite water repellent, but it's unbelievably poor at repelling oils. It means you get stains, you get smells. If you have silicone cookware, you're probably used to it sucking up smells and flavors. It's because silicone is not resistant to oil whatsoever, while PTFE is. Now, a lot of people, you know, you need your PFAS to reporting for Maine. Everybody looks at restrictions. There are big time restrictions coming to you. It's not going to be as broad as people think. It might be initially. So what's going to happen is February 7th, 6 days from now, they're going to announce some very broad restrictions of some sort for PFAS. Maybe restricted consumer, maybe not, but very big proposal. That's the biggest it's going to get. What's going to actually be the restriction is going to be a smaller version of that. So it's going to have 6 months of consultation, which is the key point to insert your feedback. Because if you want and can justify, which in a lot of cases, PFAS is so inert, you should be able to easily justify a use, you want to get it in there because if you don't ask for it, you don't get it. So there's a proposal for 6 months. Meanwhile, there's the technical committee review, which will probably start in April, the SEAC and the other one whose name escapes me. They'll go on for about a year. Nothing can happen until that one's done. It's going to say technically whether or not this meets the rules. And this actually is a big part of forcing them to only do the parts that are dangerous. If PTFE has no PFOA in it, pretty inert, it's pretty hard to restrict. Because you can make it just fine. Once the manufacturers knew you couldn't have PFOA in it, literally, first they can move to PFOA is 8 octa, they can move to 6, and then they can put a scrubber in it just to pull the 6 out. Because it's really there unintentionally, just scrub it out. So they'll finish that in April 2024. There'll be a draft text probably in the September 2024 timeframe. And then the EU legislative process kicks in. And so the Parliament and the Commission and the Council will horse trade, like doing with the battery directive regulation. It'll take a while. If they really go quickly, it'll be May 2025. They'll eventually have a final text published once they make the agreement, which will take a little while. There'll be a have your say consultation, the final one, which will take a couple more months. It'll then get published probably the earliest December 2025, and the earliest restrictions will probably end of year 2027. And they'll be very sector specific off the bat, like no, PFAS in food contact materials, no fluoropolymers in consumer fabric or something like that. Medical devices, Likely if they're included, which they might have broad restrictions, we're looking at 2030. Realistically, the PFOA restrictions already deal with all the dangerous use of the chemical. What's dangerous about these chemicals is PTFE is absolutely inert. It's a processing aid that can be used to make it. It doesn't degrade from PTFE. PTFE does not degrade into PFOA. It's just a manufacturing aid that's used in it. That at high concentrations, it affects your kidney function. It's a surfactant. It affects the protein surfactant in your kidneys. If you get enough of it, your kidney function will degrade, which can create lots of problems, including kidney cancer. But so does your laundry detergent. Your laundry detergent's a very effective surfactant, way higher concentration. It can do the exact same thing. People are saying, hey, we're finding PFOA in the water supply. The PFOA in the water supply, they're finding it because the new LC-MS, whoever designed those is a pretty amazing person, detects parts per trillion, like all 7 atoms of it. And the other reason is the third last item here. The reason it's in the water supply is not PTFE. That PFOA, that's residual, that trace parts per billion is embedded deep in the PTFE. It's not going anywhere. PTFE is as water and oil resistance you get. Nothing's coming out of that. It's really resistant to chemicals. It's the least dangerous substance you probably come across. However, the main source looks to be the cosmetics. So until about 2022, virtually all the high SPF cosmetics, and you can see in the PFOA prosecutions in Prop 65, it's the high SPF underlayer and bronzer makeup. Creates it silky. It's the ingredient C9 to C15 fluoroalkyl phosphate, which is PFOA with a phosphate in the end, basically. And it's PFOA and larger, and that's where it's been coming from. If you look what's getting in the water supply, it's literally an ingredient. The chemical they're measuring in the water supply is literally a major ingredient in cosmetics that are literally flushed down the drain during showering and cleaning or otherwise. That's where it's coming from. So they blame 3M and DuPont and stuff like that, but realistically, what you find in the water supply is coming from cosmetics. A little bit from firefighting foams, but people don't use firefighting foams that often. You think how many times in life you've sprayed a fire extinguisher versus somebody's put on makeup? You wouldn't even see the two on the same page. So one quality issue a lot of companies are going to see, unexpected. There's a PFAS use that is not part of your product, but will affect your product. When you get a part machined, especially if it's invasive medical, or you're going to electroplate it, you want it very much clean. So when they machine it, they'll end up with oil over top, and then you clean that off. And depending on your application, cleaning it off has different levels of importance. If it's invasive medical, or you're going to electroplate it, you need it pretty clean. Otherwise, the electroplating won't stick to it. The common solvent degreaser is fluorinated ether. And it's a gas degreasing machines, and they've been using it forever. And the main, chemical provider for it has been 3M. As 3M exits the market, there are alternatives. As people move to alternatives, the problem is not that the alternatives can't do the job. It's just the machine has been optimized over the years for the 3M product. And you're going to see degreasing quality problems. So you're going to see problems with machine parts and electroplated parts that have really strong cleanliness requirements. And we're already seeing this. We're already seeing ones, in the grooves, the windings, you're seeing stuff gummed up there, electroplated parts having adhesion problems. And that's because the change in the solvent degreasers, changing fluorochemicals. So that's a very unintended use. There's really no fluorochemical left from the degreaser on your product. It's been used, but its changeover will affect a lot of the quality of your product. It's not as well known. It's pretty common though. And so the middle block here, the reason I've highlighted is the ones that are mostly physical products. The ones outside of that, other than the very bottom halogenated flame retardant, are generally more in chemicals. So why do you find intentionally added PFASs in your product? Well, I'll talk about intentional and unintentional restricted ones. So intentionally, the main use of Teflon, PTFE powder, is they make a powder. And then they take the powder and they put it in a mold and they heat the mold up to 400 degrees Celsius, and it fuses and it creates a physical part. That's a Teflon part. Or if it's on metal, they powder coat the metal, heat up to 400 degrees C, and that's the Teflon coating in the pan. But it's really powder, then put into a mold and melted, or put it onto the metal and melted. Why? So the intentionally added chemicals, PTFE. PFOA may be present because it can be used as a processing aid, as a surfactant in the manufacturing of PTFE, and has a huge impact on controlling the size of the PTFE powder. But Octa's 8, you can use 6, the smaller version, which is not as regulated, or other options. And now that they know it's a problem, the facility can actually scrub it out at the powder level for the most part. So if you're reporting for Maine or the US, you're reporting the PTFE. because you're intentionally adding it. The PFOA is not reportable in Maine because it's not intentional. However, it is banned in the EU. So this Teflon part, if you don't know where all your PTFE parts are, you're very vulnerable in the EU because you can easily have PFOA. You don't have to. Having PTFE does not mean you have PFOA. It means you can. It just depends what processing it is. It's not part of PTFE. PTFE does not degrade into PFOA. It's not a degradation product. It's none of those things. It's literally a manufacturing aid that could be added and doesn't have to be. There are other options. It's better at it, but it doesn't have to be. So that's solid PTFE or metal-coated PTFE. Another solid one is pretty funny. It's actually PTFE tape. PTFE tape is actually a solid done in the same way. So what you do is you take the powder, you put it into a mold of a huge cylinder, you fuse it, just like the stuff on the left, you heat it up, you fuse it, and you create this hard cylinder. Then you skive it. And skiving is basically peeling. You put a blade on it, and you peel super thin layers off the solid piece. That's skiving. And then you take that super thin, you add adhesive to it, then release paper, and you roll it again into a second roll, and then you section it, and that's PTFE tape. So PTFE tape is intentionally added PTFE powder, which is fused together in a solid and then skived off, basically peeled. It can have PFOA residual because if the powder was manufactured, PFOA is manufacturing aid, the tape will have it. But it doesn't have to be. But the PTFE tape is actually just a super thin version of the solid, and they make a solid, they skin it off. Where we see in electronics almost the most is as a coating. And this is PVDF. It's vinylidene fluoride. It's not PTFE, which is tetrafluoroethylene. It's a very slightly different polymer. And so what you do is you make PVDF powder, which is very similar to PTFE powder. You put it into a protopolar solvent. Think of it as acetone. They're not. They're higher end. They're DMAC or NMP. They're almost always SVHCs. They put it in a solvent. They paint it on. Solvent dries. You're left over with PVDF. And so when we see we see it in electronics all the time because in a cable, the wires are often coated with it to make them frictionless so you can bend them. Or if you have that little paper strain relief up them and it's very flexible, the strain relief paper will be PVDF coated. They'll say PTFE coated, but it's really PVDF coated. They're very similar, but that's a typical fluoro coating. And will the average supplier, which has a cable in their product, know it's in there? No. If you're doing data gathering with suppliers, good luck. These applications are well beyond the knowledge base. And it's probably one of the most common places we find fluoropolymers is inside cables, because if they coat them lightly, the cables for the strain relief, and that adds the low friction. So when they bend, they don't bind, and the flexible cable lasts a lot longer. And that's a PVDF coating. It can have PFOA from the original PFDF manufacturing. We often really see a sulfonated fluorotelmer called 6,2-fluorotelmer. Then more often than we see PFOA in this situation, which is not regulated at this point in time outside of carpets. But the PFOA that's in there, or the 6,2-fluorotelmer sulfonate, are unintentional, not reportable. The PFOA, if it was there, is restricted. But it doesn't have to be. There's lots of other choices. The 6,2-fluorotelmer sulfonate being the most common manufacturing aid, or its family, for making this situation. Again, it's powder, dissolved into a solvent. It's actually a solvent mixture. It's kind of a little more complicated than that, and then coated like a paint, and then dried, and that's the PVDF coating. We see it in wire and cable all the time to reduce friction. So there's also PTFE wires. That's a different thing. That's usually made through the fusing process of the powder. This is a coating on the surface for friction. Pretty darn common in wire and cable. This is the one you see in fabric normally. So when you look at the prosecutions for like North Face jacket and stuff like that in Prop 65, they would be most likely using side chain PFASs. And it's a little bit different. So it's an acrylic polymer, like your contact lenses or a paint. And the acrylic goes one way, and then every so often the acrylic polymer, they have a side chain sticking out the side of a PFAS. They're called side chain PFASs, side chain fluoros. It's basically an ester bridge connecting a fluoro, and it'll be usually a fluorotelmer of some sort. There'll be 2 carbon hydrogens and a whole bunch of carbon fluorines. During the manufacturing process, that ester, the O, can break, and you have one in a million of these loose, and some of them will become like PFOA or whatever its length is. So there's a possibility when this chemical is manufactured to have some residual PFOA, and it's really an impurity because of the PFAS side chain can fall apart. They can actually filter that out, and they can move to shorter chains. Now, the reason why this is so water repellent again is the outside of the fabric, what the person is touching, or the outside environment, is a fluorocarbon. It'll have very low surface electric charge, which means it's extremely water repellent and extremely low friction. It'll also be oil repellent. That's one of the big differences. It and silicone, you could silicone coat something, but it's not oil resistant, it's only water resistant. Like your Head and Shoulders shampoo is silicone rubber, and they just coat your hair with silicone rubber, and that is water resistant, but it's not oil or air resistant. The fluoropolymers are oil and water resistant, so you won't get stains or smells from it either. It's very advantageous. The downside when it's made, it could have some chemicals break off, become trace levels of PFOA. That's probably manageable actually, and it's extremely trace. That's not going to affect your kidneys. But it is measured in Prop 65, and there was a number of prosecution notices around that. Very common in a lot of products is PTFE grease. It's basically PTFE powder, like the original one. The powder, instead of being fused, is suspended in mineral oil or silicone oil. It can have PFOA present because PFOA can be used to control the powder side of PTFE by being a surfactant in the manufacturing process. It's unintentional. You wouldn't have to declare it. You would just declare the PTFE powder. However, you still have to be PFOA free from the purposes of Europe. So that's a typical lube. Where a lot of the industrial products used is fluoroelastomers like FKM. It's basically a VDF. So it's of the PVDF family. It's a VDF monomer, a little bit, with a secondary fluoromonomer of some kind. It could be tetrafluoroethylene. And it comes in a gas, it's the oil side. You add a water, you put a surfactant like PFOS. So the surfactant is also why these PFOS and PFOA are used. They're to mix oil and water. Because inside the water is the thing that makes the monomers connect, bind and become a polymer and become the plastic, is the potassium persulfonate, KPS. That's the initiator. It causes the different monomers to bind to create longer chains, which is a polymer. That creates a plastic. We're not trying to create a PVDF or Kynar plastic. So Kynar is a solid PVDF. It's the tubing, see it for a lot of water or chemical. It's rigid. If you want the rubber version, you have to vulcanize it. You have to cross-link the different polymers. They have to cross-link so it becomes a jumbo cross-linked instead of rigid, jumbo cross-linked, and it becomes a rubber. So you have to add a cross-linker, which is peroxide or bisphenol A fluoride, fluoro. It's bisphenol AF, which makes for laughs of this place, but it's the fluorinated BPA or peroxide. It's the cross-linker, and that creates the PVDF elastomer. This is the fluoro rubber. So it's the your Viton gasket or your fluoro smartwatch band. That is a fluoroelastomer. And that's a different application, and it's basically making a solid from scratch and powder. Then you end up with a powder, and then you add a cross-linker, which vulcanizes it into a rubber. It connects all the powder together into a rubber, as opposed to a solid plastic. Skip through this one pretty quickly. If you're in the pharmaceutical side, the chemical side, you'll use this every so often, where you'll have some chemicals that attack high-density polyethylene. So you can't put your chemical in your typical polyethylene container. So you have to fluoro-oxygenate it, make fluoropolyethylene by bombarding it from fluorine and oxygen. However, the oxygen fluorine will sometimes accidentally create carboxylates and create PFOA. It's not intentional. The intentional material is fluorinated polyethylene, and that's your report. But you can actually unintentionally create PFOA. And then one really different application is perfluorobutyl sulfonate, butane sulfonate. 4 is sometimes used as a halogenated flame retardant in polycarbonate. We see this once a month or so. It's usually pretty low concentration, but it's a flame retardant for polycarbonate. Totally different use. It's because the fluorines will pop off like a bromine does. PFBS is much more compatible with polycarbonate. It's a chain of 4. So if you ever do alkane chemistry, it's methyls 1, ethyls 2, propyls 3, butyls 4. It's monkeys eat peanut butter, methyl, ethyl, propyl, butyl. If you take any useful thing away from this, if you're doing, organic chem, it's monkeys eat peanut butter, methyl, ethyl, propyl, butyl. That's the order. B is butyl, which is 4. So if you do reporting, say for Maine, you can do it by product family. You have to describe the family, the tariff code, the intended use of the product, and then what's the purpose, the PFAS, the weight, and CAS number. And we handle all that for you. Doing CAS numbers of fluoropolymers is something. Whatever you learned in high school in chemistry, you're not ready for polymer chemistry. It's something where you have this basic 1 CAS number, which seems to cover a lot of very different situations and how to handle that. You can't just say, hey, I tested and I've got this CAS number. That's what you do for PFOA. That's not what you do for PTFE. It's much more complicated than that. Then you need your contact information and et cetera. And so this is what you need for reporting of intentionally added PFASs. So your PTFE solid is intentionally added. Your PVDF coating is intentionally added. Your accidental PFOA manufacturing aid is not reportable in Maine. It's unintentional. However, it's still banned in the EU. And the longer chain versions, the more extended version, are banned as of this month in Europe. So if you don't know where your fluoropolymers are at this point in time, you're already probably dead in the water for the European restriction. So as much as you're worried about, a lot of people worry about the 2027 restriction or a 2030 restriction for EU, what its scope is going to be, you already have the DFAC. You have basically a similar restriction already in place. It's, if you don't know whether you have them or not, then there's no way you know whether or not you have the banned substance in them, because the banned substance only exists in other fluoropolymers. So the PFOA longer only really exists in fluoropolymers. If you don't know where your fluoropolymers are, there's no way you know your EU restriction right now. And Sweden just had an enforcement on PFOA this past month and caught lots of people. So easily go back to the beginning. For PFAS, it's really easy. You have products. We can fix it for you, make it really easy. We'll give you the reporting for Maine and US federally, and also your due diligence for restrictions. It's really easy. When in doubt, ask us. It's like, I have all these products. This is the cost. This is how long it's going to take. It's really straightforward. Back onto the original topics. If you haven't done SCIP before, it's straightforward for us to build the SCIP required SCIP files and help you register them. If you've already done SCIP or we've done it for you, it's really easy to do the updates for us because we do this for tons of people. If you had to do it once, it's probably a pain in the butt. If you do it, hundreds of times, you end up with some pretty rigorous processes that work really well. So I went a little bit long here and I went a little bit fast. By the end, I was speaking at Mach 2 or faster. My mother would not be impressed. However, she would say what a lot. I would get that in my comments section. She'd be asking questions all the time. So maybe it's better she didn't hear this. So if you have any questions, put it in the control panel. I'll try to get to as many as possible. If I don't get your question, please feel free to reach out. Again, anybody who registered will receive a copy of the slides, hopefully by tomorrow, and there should be a online recording of this within the next day or two. First question, tetrabromo bisphenol A and RHS, is that restricted for PCBAs? It will. So it will be restricted when the EU Commission gets around to it, which they're probably going to wait for the new RHS regulation to punt that over to the European Chemical Agency to handle. The use of tetrabromo bisphenol A to create brominated polycarbonate. So tetrabromo bisphenol A is banned in brominated polycarbonate, probably at 1,000 ppm when the RHS restriction comes in, which is still no timeline, but there won't be there. So even though your FR4 circuit board, the brominated polycarbonate is made originally from tetrabromo bisphenol A, there's very little tetrabromo bisphenol A left. It's fully reactive, and so it doesn't really affect the ingredient to your FR4 circuit board. So when it gets restricted, it will be restricted to PCBAs, but it'll have virtually no impact on them because the chemical using your PCBAs is very different. It's brominated polycarbonate. It's not tetrabromo bisphenol A. Do you have any insight on the France regulation on packaging restrictions of mineral oils? It's generally around food contact packaging, around MOAH, and I can't for the life of me remember the other chemical. When in doubt, reach out. They should be visually obvious. If you have mineral oil in your packaging, it'll be visibly obvious for the most part. And it's really around food contact packaging. You can argue it for consumer, but it's really around food contacting. Are fluorosilicons considered polymeric PFASs? Generally, yes. Fluorosilicon polymers are, fluorosilicon monomers are not. So I'm definitely working on two different chemicals right now. Fluorosilicone polymers are rare. I didn't talk about them today, but they do exist. Fluorosilicone, there's some additives for adhesion that are not polymers. They're not. So there are fluorosilicon polymers are PFASs and reportable. Fluorosilicon monomers are also PFASs, but are generally not reportable. But fluorosilicones are almost, as long as you have the carbon of the two fluorines or the carbon of the three fluorines, you're in scope. There are some silicone molecules I've seen which have a single fluorine. That doesn't count. It has to have the two or three. Oh, sorry, I'm going a bit over time. Thanks again for all the questions. Yes, good question. How can we get a quote? Just email us after this or respond to the webinar email. We'd be happy to help. We do tons of this. At least you can see a way to do this. And if you want just to see how and get an explanation how to do any of these things, you just get a quote and we'll explain how it's actually done. And whether or not we do it for you or not, you have a good idea how somebody else does it. Now, one thing you're going to see with us, it's going to be pretty rare for us to be reaching out and bothering you. It's not normally our approach. We spend most of our effort in actually creating the processes to do this. You probably have gotten to the point right now, you may or may not have realized that we don't reach out with salespeople all the time. It's not what we do. We'd rather provide education. We try to provide value and content, and people come to us because hopefully we can answer their question, not because our salesperson is bothering you every week. At most, you might see a mailer coming up on PFAS's, the REACH SVHCs, just to say what we can do, but we generally don't bother you too much. So happy people come and attend. Huge attendance of both of them today. Very, very great to hear from everyone again. And thanks everyone for attending, and I hope to talk to everyone again soon.